Hi, it's time to move on. We're going to start theme 5 today. So, for this lesson, you're going to need your blue theme 5 booklets. Okay, then, let's go. This theme is all about igneous rocks. We need to start looking at, first of all, what igneous rocks are, how we can define them, how we can classify them, what they actually tell us. And we're then going to move on to start thinking about some of the features that they make, and in particular to look at volcanic activity, nature's big show, because the igneous rocks that we can find that have been erupted from a volcano actually tell us an awful lot about how that volcano behaves. They can, for example, help us predict what future eruptions might look like. Anyway, when we start a new theme, as ever, we need to sort out some definitions. So we need to have a look at what's in a word. So if you turn your booklets to the inside of the back cover, we have 7 different terms here. We need to see what you think about what the definition might be. Some of these may be familiar to you already. Others, though, almost certainly will be new. That one in particular. Okay? So for those terms, what do you think? What do you think those terms might mean? Remember, at the start of a theme, I don't know is a perfectly acceptable answer. So, press pause now and have a go at that. Okay then, let's move it on. We're working today on pages 2 and 3 of your booklets. We should perhaps start by thinking about what magma actually is. Igneous rocks are formed when magma freezes. So the raw material of an igneous rock is going to be what's in the magma. And there's a mixture of things that we find in magma. Perhaps the most obvious is molten rock. Rock that's been heated, bonds have broken, and it's turned to a liquid. Most of that is made of a group of minerals we call silicates. We'll talk a bit more about those in a moment. But it's not just molten rock. We also get steam. Water is a really important feature in igneous rocks, particularly when we start looking at why rocks melt in theme 7. It's also a mixture of poisonous gases, carbon dioxide, sulfur gases, carbon monoxide, all sorts of really quite chlorine gases, all sorts of unpleasant things. And finally, as well, associated with most volcanoes is the sulfur. You can often see this yellow incrustation around the volcanic vents, which is elemental sulfur. Perhaps one of the most distinctive things, though, is the smell you get around volcanoes. The bad egg smell. It's very, very distinctive. Even to the point where, if you have a shower in Reykjavik, when you turn the shower on in Iceland, you can smell the sulfur that's from the magma that's been used to heat the water. It's very, very distinctive, very characteristic of volcanic areas. There is a video clip that goes with this to talk about some of the things that go in volcanoes. Have a watch of that. It's well worth seeing. Okay, the main part of today's lesson is to look at this. This is what we call the classification of igneous rocks. This is how we tell igneous rocks apart from each other. We do this using two features of the igneous rocks. You have this table on page 3 of your booklet. The first feature we look at is what we call the texture of an igneous rock. Now, the texture is the size of the crystals in the igneous rock. And we divide it up into 4 different groups. Coarse igneous rocks, coarsely crystalline igneous rocks, have crystals that are bigger than 3 millimeters across. Medium crystals are between 1 and 3 millimeters across. Fine crystals are less than 1 millimeter across, but you can still see that there are crystals there. And finally, glassy, which is an igneous rock where you can't see any crystals at all, even with a hand lens or possibly even a microscope. They're just not going to be visible. So the first thing we do when we look at an igneous rock is we look at how big the crystals are, because that'll tell us which of those divisions we could put an igneous rock into. So for example, on your table you'll see that gabbro is a rock that has coarse crystals. So a rock can't be a gabbro unless its crystals are bigger than 3 millimeters across. The second feature we use is the minerals that we find within it. Now, the graph at the top of this table gives us an indication about how these minerals change. So, for example, the rock rhyolite will have a significant concentration or significant content, should I say, of quartz, with some feldspar and maybe some mica in there as well. A gabbro, on the other hand, has no quartz at all. It's mostly made of plagioclase and ferromagnesium minerals like augite. Augite is the ferromagnesium mineral. And there's a bit of olivine in it. So we can see how these the amount of these different minerals changes with different compositions. So for example, if we have an igneous rock that has crystals that are 2 millimeters across, it's mostly made of plagioclase and augite, there's a bit of olivine in there, that rock's going to be a dolerite. So we can use both of these things, both of these features, to identify igneous rocks. Now you'll notice that there are some gaps on this table. What I want you to do is I want you to fill these gaps in. These are the 6 rocks you need to know for your GCSE geology. These are the ones you can be asked to identify. These are peridotite, granite, dolerite, basalt, obsidian and andesite. I'd like you to look at these rocks, and in particular there's a separate video where I describe each of these rocks for you to fill in your table. The minerals that we find in an igneous rock are, as I said before, silicate minerals. These are minerals that contain lots of silica. All igneous rocks, by and large, are made of some combination of these minerals. We have olivine, which is sort of a green, glassy colour. Plagioclase feldspar, which is white. Orthoclase feldspar, which is pink. Quartz, which is sort of grey, glassy, maybe see-through a little bit. Biotite is black and flaky. Muscovite mica is white and flaky. And augite, which is black. Watch the video that describes the rocks. And what I'd then like you to do, for each of those 6 rocks, well, one of them's done for you, so each of the remaining 5 rocks, I would like you to write in their names in the correct place on the table on page 3. So now's the time to press pause, watch the rock description video, and fill in the rock names on that table. Have a go at that now. Okay then, let's just check your answers so we have an accurate start of this table. This is the table we're filling in. The first of these rocks, specimen X, is granite. Now granite is has got coarse crystals, and it has a significant quantity of quartz within it. That puts it in that top left hand corner of our table. Our second rock, very different to the granite, specimen Y, is basalt. Basalt is dark in colour because of all the augite that's in it. There's a little bit of olivine as well, but it's the augite that really stands out there. It also has very fine crystals, less than 1 millimetre across. The third rock is possibly the trickiest one for us to identify. This is andesite. Andesite is in the middle there, and its composition is a little bit in the middle as well. It's not the easiest one to identify because it does share some characteristics of the rocks either side of it. If you are asked questions about it, it's going to be quite obvious what it is. As we'll see, andesite is actually really important when it comes to understanding volcanic eruptions. But again, that has fine crystals, less than 1 millimetre across. Our next rock is perhaps the most obvious of all. One for Minecrafters out there, this is obsidian. Obsidian is a volcanic glass. Black in colour, but you can't see any crystals. It's very, very distinctive stuff. Finally then, we have peridotite. Peridotite is quite an unusual rock. Certainly at the surface, we find it fills up the mantle of the Earth, but at the surface it's relatively unusual for reasons we'll get into. But it is quite distinctive. It's got a lot of olivine in. So the green colour of that rock really makes it stand out as being right down at the right hand side of this table. You can see on this table that there are some areas that I've blacked out. Rocks do exist in those areas. We don't need to worry about them for GCSE. Okay. So, as the sun sets on Half Dome in Yosemite, which is an enormous mountain of granite, we can see that there are 2 key ways that we classify igneous rocks. It's really important that we get to grips with those and understand those if we're going to understand the rest of this topic. If you've got any questions, don't be afraid to ask. Next time, we need to have a look at some of the other properties that these igneous rocks have. But that's for another lesson. I'll see you then.